Құрметті көрермендер, бүгін біз басқа Каспий деңгейінен 25 минут төмен ғылыми подкастымызды бастаймыз. Today our guest is professor from Guilan University, Iran. It's a rich city on the southern part of the Caspian Sea. So somehow we connected through the sea together. This is Professor Vahid Mottaghitalab.
Yes.
Nice to meet you. Welcome in Atral.
Nice to meet you. Thank you very much for inviting me to this very good talk. And I would like first thank you and the leadership team of the Otыны Oil and Gas University for inviting me for research cooperation. And thank you very much for inviting me to this podcast and I would like to have a great talk for audience.
Today the topic of our discussion would be the hydrogen in any way of the production and consumption. And my first question to you, Vahid, why the hydrogen looking for so promising for the future as a source of energy? Why namely hydrogen?
Yes. Actually, let me first focus on three important points. First of all, hydrogen names as a zero emission fuels for the future from two different views, from the in production process and as well in application. In production process, we have several actually processes that can produce hydrogen with zero emission to atmosphere. And in application, it can be used directly and indirectly as a fuel without any emission to atmosphere and cooperation for to help against thermal, climate change increasing temperature of the global temperature. So this is the first point. The second point that hydrogen...
Let me disturb the result of the hydrogen combustion is water.
Yes, that's the point, without any carbon footprint. And that caused that the hydrogen is named as a clean fuels. So, and second important point for hydrogen is very high energy density. We have two definitions for hydrogen. Energy density is gravimetrical and volumetrical. And from the gravimetrical viewpoint, it's for hydrogen called for 120 megajoule per kilogram. It's triple of the gasoline and 240 times of the batteries. The battery is 0.5 megajoule per kilogram. It is a huge number compared to
the most energetic material in chemical sense
currently that we have. But still, there are some challenges I will say in the rest of our talk. The third point that's very, very important is versatility. From versatility point, it can be produced from different sources: natural gas, water, biomass, associated gas, coals, different sources, and different processes as well. From the application viewpoint, it can be used in heavy industry, transport, and as well storage of the energy when we need some balance in the grid network. That's cause that the hydrogen is very promising for future energy carriers.
Thank you very much. Let's shift our discussion to the production. So what are the basic ways of the hydrogen production? Because in Atrau we like focusing on the basically in the hydrocarbon the production and and refining of hydrocarbons, and of course the plant here also produce hydrogen, but it's the hydrogen which the direct result of the carbon emission production, and also this hydrogen consumes plant itself for the like for some further chemical purposes. But what are the main alternative types of production?
Yes. As you said, currently hydrogen can be produced widely with cost-effective maybe method is SMR, steam methane reforming, that use methane or natural gas and produce hydrogen plus CO2.
Yeah.
For every ton of hydrogen, we produce 9 tons of the CO2, and it is very,
not green technology.
not very good actually for the future, and it's corporate for global warming, and so we need to substitute these methods, but with new method. We call it that method that produce hydrogen. It's gray hydrogen. Beside of this, we have blue hydrogen that is completely same as gray hydrogen from process viewpoint, but it capture and storage all of the produced CO2 or most of the CO2, not all of them. That's cause that the blue hydrogen is not completely zero emission actually method. So the blue hydrogen is same as gray hydrogen, but it has some other unit to capture and storage CO2, but not totally. Beside of this method, we generally use a term green hydrogen. For green hydrogen method, there is the lowest amount of the CO2 fingerprint. Why I said the lowest? Because even solar, wind, that we known as clean energy has some fingerprint of the CO2 in the production process of the material used for this material.
Yeah.
So we assume that the green hydrogen using electricity to water splitting to produce oxygen and hydrogen, and using renewable energy, wind and solar and other sources as well. Hydropower maybe based on the region that you are. So you produce hydrogen by this method without any CO2 fingerprint in the process. And then this is the green hydrogen. We have as well other color, such as pink hydrogen that use nuclear energy for producing electricity or producing the thermal energy to change the materials using different sort of the material to produce hydrogen. We have brown hydrogen that use coal, waste, biomass, agricultural waste, even sewage waste. Different material, different process, different source, different method. It makes it very versatile. And from the production, from the application viewpoint as well, it is very versatile. It can be used for heavy industry, it can be heavy duty vehicle, and as well as storage. That makes the hydrogen is very powerful for the future.
So literally green energy, green hydrogen comes from only electrolysis.
Not only this method, there are some other methods as well using pyrolysis, that using associated gas.
But it also produces carbon.
It produces carbon residue by methods like microwave and as well plasma That's very high electrical energy need. So we produce hydrogen with carbon residue. That carbon residue can be used in ink industry, in paint on industry, in several industry, not CO2 that can be emitted in the atmosphere and very harmful.
Yeah, thank you very much. So you mentioned the alternative way of production, but what do you think? So right now they are more expensive than classical cost-effective reforming for the production of all. They require a lot of energy. So what is the maybe breakthrough technology in a close future which could replace, substitute this the gray hydrogen production?
Actually, the green hydrogen that is now going to produce the gas of hydrogen, it need to be stored and as well actually transported. For both of them, we have challenges because hydrogen, a very small molecules, and for storage, it needs some sort of the vessel is can resist against penetration of the hydrogen. So lots of research is going to be done to make some storage against penetration of the hydrogen small molecule, so it can be stored for the future. Another challenges that we have for transportation of for hydrogen, its effect on embrittlement of the pipeline. It make a fragile material for transportation, and in the over time it crack and destroy the pipeline. So the current pipeline needs to be substituted with new actually infrastructure for the transferring that. So to address these challenges, we need some other materials, such as the metal hydride, such as the liquid hydrogen carrier that can store the hydrogen
in liquid.
In liquid and in a solid situation, solid phase, and release hydrogen steadily by a stimulus of the heat and other things. So it can be stored and captured, safely transferred. Other methods to storage and transfer that, using the high pressure, more than 700 bar of the hydrogen, or the cryogenic techniques that using the cooling under minus 235 degree. That is more consuming energy, and maybe we need some other method to preserve this sort of energy. Yeah.
So anyway, it's better to, if you have the sources for production of the hydrogen, not to store much, but use immediately for some local purposes. Is it a good way for sustainable, cost-effective technology?
It's not just simple that as you are telling that, because for example, if we say about the storage of hydrogen, means that when you use electricity to produce hydrogen, it can be saved for that time that we have not any source of energy and used for the energy. So it needs to be stored. So a storage of the hydrogen in liquid form is inevitable. We need some technology to store it, pressurize it, and cool it, and save it, and actually capture it. So they're all together help us to for the future to make hydrogen as a productive fuel to be used in network. For example, there are some we have lots of the cloudy that so we can't produce actually solar. But and as well, we have some days that are not windy, that we can produce energy from this day. But there are some days that we have excess energy from this one. So the excess energy from the wind and solar can be used for producing hydrogen from the electrolysis, and it is stored in another situation instead of the wind and solar. This is the circular things that can be used in the process. Yeah.
But what do you think about the this composition? So the Atrau region is the region for hydrocarbon production, and most hydrocarbon in this area, it's a carbon saturated with deficit of the hydrogen. So it's more aromatic with some paraffin or the condensed the hydrocarbon substances with deficit of hydrogen. If we combine and that's why our production is a very carbon dioxide emissive. So if we combine the emission of carbon dioxide with new sustainable hydrogen the production, can we look at the new area of the chemical consuming hydrogen for further transformation?
Yeah, fantastic method. That this is a network of the material. We produce hydrogen. We cannot flee from the CO2 sources. This is the reality. So when we're talking about the CO2 conversion, this is exactly we need hydrogen sources. So hydrogen can be used directly as a fuels, and hydrogen can be used as actually reactant beside of the CO2 to make some other chemical and fuel again. It is sustainable method and the network that can actually circulate CO2 and H2 to produce chemicals such as a methanol. Methanol is such as a hub point to produce lots of chemicals, and methanol as well. It produced from the CO2 and hydrogen in the process that all chemical engineers know.
Yeah.
So again, this sort of materials comes into the road to making new material, new chemicals, new fuels for the future.
Without emission of carbon.
No, without emission. Although those chemicals, when burn, produce CO2, but this CO2 again back to this cycle to be consumed for producing new chemical without using extra fossil fuels from the underground that make very unsustainable.
More effective.
Yeah, that's it.
Okay, so let's briefly discuss about the hydrogen fuel car, how they could be competitive with electrical.
Actually, both of them are two options that should not be omitted against the other. For example, the battery vehicles can be used for general transport that normally people use.
Yes.
But for those sections that need to be decarbonized, we have decarbonized system and hard to electrify, for example, for heavy industry, for heavy vehicles and storage, we need hydrogen. So the fuel cell vehicles compared to the actually battery vehicles for natural transport, for general car that everybody use, may be less effective. But if we use heavy duty, such as the car, ship, trucks, heavy duty cars, ships, trucks, planes, everything that need very high dense fuels and very fast refueling systems, it takes a few minutes in hydrogen to be refueled compared to the battery one that take I don't know exactly a few hours maybe. So the fast refuelings and as well, very high dense energy for this sort of the vehicles that use hydrogen in a fuel cell process is very useful for those heavy duty issues actually. Yeah.
Oh, thank you. So, and traditionally, our last question about some near future, like looking ahead in for 5-10 years. So just imagine how optimistic you about the future of hydrogen energy in the near future.
Actually, in the future, what we have in front of hydrogen industry is quite bright. But for reaching that point, we need several factors to be actually to be realized. First of all, those who policymakers and need to be focused on this point and just try to help this industry to be improved. Secondly, actually, the cooperation between the private sector and public sector to most investment in this area is very important point to be actually point out. And thirdly, research and development in industry by industry support for the in institutes, research institutes to just tackle the challenges now hydrogen industry actually facing about that. It's very important. So fortunately, so many countries now try to make a very, a road to make hydrogen industry brilliant, such as Japan, such as South Korea. Already Japan try to, put the cars in the road, 800,000 cars by 2030, and already made a car by fuel cell Toyota Mirai in this category. South Korea as well, actually plan to make 6,200,000 cars by 2040 and 1,200 refuel stations for hydrogen car, vehicle cars. That's bright future. And Europe working on the mega project for the pipeline of the hydrogen. This is all of the signs that hydrogen going to be developed in the near future. But all of them need a coordinated global cooperation.
Yeah, thank you very much for your optimistic opinion on hydrogen and our future and the hydrogen. And by the way, the sun also produced the most energy consuming the hydrogen. So this is we also in thermonuclear synthesis. So we are also living around hydrogen, and I believe this is our future, energy future. Thank you very much for
joining.
Yeah.
Very nice talk. Thank you.
Рахмет, құрметті көрермендер.